Hi guys, in this diagram we have a solid body that consists of a right circular cylinder which is fixed with no overlap and a rectangular block, of course, which is at the bottom. Now the rectangular block has a square base, you can see at the bottom, which has a side of 2x centimeters and a height of x, right? Now the cylinder has a radius of x as well and height of y centimeters. Now, given that the total volume is 27 centimeter cube, we have to express y in terms of x and also show that the total surface area is this. So let's start off with the volume that has been given to us. So we know that the volume is 27 centimeter cube. So since this is composed of two different solid shapes, we have to calculate the volume of each of the solid shape. So the volume of the cylinder, I say VC, C for cylinder, is pi multiplied by r squared then h. So this is pi times the radius is x squared, then the height is y. Now in the end, this is pi x squared y. Now let's go to the base, which is the rectangular block. I'm going to call this VR. The formula for calculating the volume of a cuboid is the length multiplied by the breadth multiplied by the height. So I'm going to give this the length, I'm going to give this the the breadth, and this is going to be the height, right? So this is equal to 2x multiplied by 2x, which is b, multiplied by x, which is the height. And this equals to 4x to the power of 3, right? Now the combination of these two volumes, which is VC and VR, equals 27 centimeter cube. So in the end, we have pi x squared y plus 4x cubed equals to 27. Now since we are asked to express y in terms of x, then we do pi x squared y equals 27 minus 4x cubed. Now y equals 27 minus 4x cubed divided by pi x squared. Now we have fully dealt with the volume. Now let's go to the surface area. So first, we're going to start with the cylinder, right? So the cylinder is sitting on the rectangular block, so which means that the circular base is not visible to us, so we can't see that. So the only thing that is visible to us is the cylindrical body, the curved body rather, and the base, excuse me, and the top, right? So which means that we have the top, the circular top, pi r squared plus the body, just 2 pi r h, just the curved surface.
It's 19 hours.
I beg your pardon. So this becomes pi times x squared plus 2 times pi times x times the height is y. Now we can factorize here. We can decide to do pi x into x plus 2y. We can leave it this way, right? And that's for the cylinder. We've dealt with the whole of the cylinder. Now let's come to the bottom. So I'm going to call this SC. Now for the rectangular block, remember that the upper part of the rectangular block has been partially blocked by the circular base of the cylinder. So now the total surface area of the rectangular block, which should have been 2LB plus 2LH plus 2BH, the formula is going to be altered, right? So we can clearly see that the base and what we have at the top are going to be literally the same, but we are not going to consider the upper part anymore as far as this formula is concerned. So the modification to this formula is going to be these two leaving, and then we're just considering the one at the bottom. Now by doing that, we substitute our value. We have 2x multiplied by 2x plus 2 times 2x, which is L, then h is x, plus 2 again, then 2x, then the height is x. So this becomes 4x squared plus 4x squared plus 4x squared. Now this equals 12x squared. Now, there is one part that we haven't considered. Now, we said that the cylinder is sitting on top of the rectangular block, but there is this portion of the rectangular block that is exposed. I want to believe you can see that, this part and this part. They're exposed, and so we have to, of course, factor in the fact that they are there, and it has to be part of the surface area we are considering. So how do we do that? Clearly, what we have at the top is a square. So we have a square, and then we now have a circle somewhat like this. So to find the area of this shaded portion, we calculate the area of the square, we calculate the area of the circle, and then we subtract that of the circle from the square. So the surface area of the leftover XL is going to be the area of the square, which is 2x all squared. Remember that the 2x that you have here is the same that we have here, and the one here is the same that we have here. So that's how it works. Okay, minus the area of the circle, pi r squared. Don't forget that the radius that is right here at the top is also the radius you're going to be having at the bottom. Now this equals to 4x squared minus pi x squared. Now let's add up all the surface area now. So A, which is the surface area, equals, this is the first guy we obtained, pi x plus 2y. Here's the second guy, plus 12x squared, and lastly we have 4x squared minus pi x squared. I guess we have to open the bracket again. So A equals pi x squared plus 2 pi xy plus 12x squared plus 4x squared minus pi x squared, right? Now pi x squared goes along with this, and we have A equals 2 pi xy plus 16x squared, this and this. Now y is 27 minus 4x cubed, then all of that as we've previously obtained. So all we just have to do is to substitute for y in the expression for A. So we have A equals 2 pi times x times 27 minus 4x cubed divided by pi squared plus 16x squared. Now this pi goes with this. This goes with this. So now A equals 2 times 27 minus 4x cubed divided by x plus 16x squared. So I'm just going to finish that off here. Now, when we decide to open the bracket, then this becomes 54 minus 4x cubed divided by, minus 8x cubed divided by x plus 16x squared. So A equals 54 over x minus 8x squared plus 16x squared. So A equals 54 over x plus 8x squared as required. Do you have a better way of doing this? Let me know in the comment section. Thank you.